Hello everybody, this is going to be a Grasshopper tutorial. Objective of that tutorial is going to be create sort of geometry of fins that kind of split open to create like a clear view, and they also extrude it vertically, so they actually create a little bit more shading wherever they split open. It's all being driven by that point, and based on the location of that point, there is a sort of field of influence of where that geometry distortion happens. Okay, let's get started. We want to create a new file. I want to go to perspective, and I'm going to create a new document. We're going to get started by creating a grid. So under vector, to create a square grid, we're also going to need a slider. If you double click the slider, you can set the min and max, set it to 40, connect it to X and Y. That creates a grid of points. Next thing we want to do is actually get a geometry and convert all those points into geometry. We want to simplify. This whole operation is going to be based on the distance from the one point that we're going to assign in the middle, somewhere the controlling point that we can move, to the rest of the points in the grid. So what we want to do is graft it. So under sets, I'm going to go to tree and graft tree, and drag the geometry and connect it with graft. Next thing we're going to need is a distance. It's under point. So it's going to be a distance between points on that grid and a specific point that we're going to define. So we actually want to go to params, geometry, and point, and get one point. Now if we switch back to a Rhino screen, create a point, and then go back to Grasshopper and right click, set one point, select that point, now connect it to B. That creates a calculation which measures distance between that point and all the points in the grid. So now we have to do a few operations on the list to kind of remap that and limit how many points in the grid are going to get influenced. So first thing we want to do is go to sets and shift paths, and we're going to remap all these points to be between 0 and 1, so all the distances are actually going to be just values between 0 and 1. To do that, we'll need a boundary from math, specify a boundary, and we actually want to flatten that. And then from math, we will need the remap component. So under domain, there is the remap component. So connect the shifted path and the boundary to the remap. And by default, it's set up to be from 0 to 1. So now all the numbers have been remapped to be between 0 and 1. And you can see that on the panel. Whereas before, all the distances were the actual distances. So what the boundary does is gets the minimum and the maximum value, and then takes all the numbers and remaps them based. So the maximum is going to be 1, the minimum is going to be 0. It just remaps it. So once we have that, we actually want to define a range that this point can affect the range of points. We don't want them all to get modified, we just want a range. So we need to specify kind of a Boolean operation. It's actually going to be in a math operation, smaller than. So all the remap points, and then if if you double click, this is a shortcut for a slider, and type in the number that you want and hit enter, this is going to automatically create a slider. So I'm just putting 321 in. It's just something that you can see. These are all the values. They're beginning from 0 to 1. 0.3 is a little less than half. So it's gonna just have a smaller field of influence. Now what we want to do is take all those points and dispatch them. So under sets and the list, let's do dispatch. So now all the values that are true, which means that they're smaller than the 321, we're gonna take those and we're gonna remap them again. So we need a boundary and we need to flatten that boundary yet again, and then we need to remap that. And now we want to remap that, but if you saw, it was kind of nice curve thing that was going on over there. I don't know how to say it, was like a little bulge. If we want that to happen, those numbers need to get remapped, and I'm gonna use a graph mapper for that. And if you right click on the graph mapper and under graph types pick a Bezier graph mapper, so now it's gonna take all the remap numbers from 0 to 1 and remap them yet again, but this time based on the curve. I'm just gonna make this so it's not, and I'll show you later exactly why I'm using the graph mapper. It's kind of hard to visualize right now because there's no actual geometry that we're working with. What we need now is merge those two lists for true and false based on that Boolean operation. So under sets and lists, to specify a list length, and if we decide to duplicate, that's under sets sequences. And if we drop in a panel, type in 0. So what I'm doing right now is I'm actually going to use a weave. It's under list, the weave component. And what I'm going to do is I'm going to take all the numbers that are true and been remapped, and then all the numbers that are false, and I'm going to merge them back together with the original, merge them back together into one list. And I'm going to use the true or false output of the Boolean component smaller than to as a pattern. So now you can see that here. They've all been put back together, and what happens is that all the values that are 0 are the ones that are not going to change. So like there's a field here, and that field is all numbers that actually have a value. Everything else is 0, is not going to change, and you're going to see that just in a second. So let's also build in kind of a multiplier. So let's actually go to math and do a multiplication. And again, I'm going to double click and just type in a random number. And we're going to multiply them. What that's going to do is just kind of control the size of that field, so we can always make the field bigger or smaller. Next thing we're gonna do is a vector, and I'm gonna use a vector XYZ, and we want to make this. The first thing I'm showing you guys is going to be in the Z change, so it's just going to be a change in the Z vector. Next thing we need is a move, and I'm going to show you a shortcut. So if you double click, and if you know what you're looking for, you can just do move. So you can either get your components this way, or you can go transform. This one is actually under. I don't even know. Mesh surface curve vector. I can't find my move component. Whatever. Let's keep going. So let's take the vectors to be the direction where it's moving, and it's moving in the Z direction. And what's going to be moving is all the points from the grid. So you want to actually go back to the square grid, get all the points, and connect them. So now you start seeing some change. And to better visualize that, I'm actually going to bring the curve under spline interpolate. I'm going to make curves out of this. And I'm going to select all this, and if you push down on your scroll button, it'll bring up that graphic, which is going to allow you to change a few things here. Well, something's not working properly. Makes me wonder. Makes me wonder what that was. I got the remats right. Yes, I think I connected this to geometry. Let's disconnect that. It's in geometry. Instead of points, let's just take the geometry. I think that should fix it. Yeah, so I think the mistake is it's right here. I connected, kind of created a pattern. So connecting dispatch to let's left, I connected a smaller than output. Okay, now that fixed it. You can start seeing that the lines getting deformed, and there's like a small field that's being influenced by that. However, this is just the first half. Now what we want to do is do an X direction deformation when the line is going to split open. So how are we going to achieve that? First of all, we're going to need a vector. It's going to be a 2-point vector. And based on the point, and then it's going to be all the rest of the points. So now it created what that component did, created a vector between this one point and all the points in the grid. And what that does, it sets a direction of a vector so that I can have them be split equally. I think we're going to need a vector reverse component for that. Speaking from experience, I tried that before. And then we're going to need a vector amplitude to be able to control, to be able to use that graph and all the map that we did. So based on that distance, so the distance the amplitude of the vector, which is the size of the vector. So it's actually going to be the multiplier. So once we have that, and we already defined z vector change, so what we need is to define just an x and y. So let's use a vector decompose, and all we're going to use is x and y to drive that vector. We start seeing some change has been made. So something's happening. It's not working exactly how I imagine it will be working. So actually this is not working because I added the reverse component. Let's delete that. So there we go. You can start seeing what I was talking about. So the points are actually flowing around it in the x direction, and it kind of goes up in the z direction. All we need now is to create another set of similar lines, but drop below, so we can sweep them. So what we're going to need is a vector xyz for that. And just connect the x and yz. We don't want a z, we just want a flat kind of a projection. And we're going to need, and I just control C, control V, those. And for vectors, I'm going to create another set of lines. So what that did is it duplicated the exact same lines, but kind of flat without z deformation, so they don't move up, they just kind of flat projection on what happened. I'm going to offset them, and I use a shortcut for that. There's an offset. I'm going to use a shortcut for point. I'm going to just type in 2. And we're going to need a plane in the y and z direction. So here's the plane. Here's the plane. Plane goes into D. I picked the wrong offset component. Offsets for spline. So there we go. So here's the curves. Here's the distance. Here's the plane. So now those lines get dropped below. Now we have a really nice surface to work with. Let's go to curve analysis and get endpoints. Control C, Control V those. And what I'm going to do is get endpoints for those two sets of curves. And now I'm going to use a line to connect those. And what I'm going to use that line for is to use a rail to sweep. And you can either use a shortcut like I did, or for that one you can go to surface and pick that component, sweep to. So once you have that, all we're going to need is a curves there with offset below as rail 1. Curves that we use, the ones that were placed in Z direction as rail 2. and the newly created lines at the end as a surface. And there you go. The only thing to make it look better, again, I'm selecting the whole thing and pushing down on my scroll button, disabling everything else except the sweep glass component, so I'm only seeing the geometry that I just created. And now if you right click on it and bake it, hit OK. Select all but point and move it. Then just change the visualization a bit to see it better. Here's the geometry that you've created. So these are kind of the flat planes. They're just changed in one direction and they open up. Thank you for listening.